All right, here we go. 6.2. It's like a marathon session for me on this end, at least. Okay, 6.2. And there it goes again. All right. Oh, at least I got my colors back. Okay, 6.2. Take notes. Oh, that's not the one I like either. Okay, 6.2. Take notes. Hopefully, you are checking in for attendance and keeping up with the homework. All right, so more on trig equations. Okay, so in 6.1, we looked at very basic trig equations and how to solve them using a calculator and using factoring. So here, what we're going to do is we're going to look at solving trig equations using identities. So you might have to convert parts of the equation into something else to make the equation easier to solve. We might have fractions, so we are going to clear our fractions. We might not have anything to work with, and so squaring both sides might actually make it easier for us to solve. Okay, so we're going to take a look at using all three of these. All right, so let's take a look at this first example here. Suppose you have to solve 2 cosine x minus 1 equals secant x. If x is somewhere between 0 and 2 pi. Okay, so we kind of like this. We don't have to do that whole whatever our answer is plus 360 degrees times k or times n. Okay. All right, and then we also see here that our answer should be in radians. Okay, so 2, I'm going to go ahead and write this down here. 2 cosine x minus 1 equals secant x. All right, so here we have 2 different trig functions. So this is a good example of when we would use one of our basic identities to convert the trig functions here into a different one. That way we have to deal with only one type of trig function instead of 2. All right, so I'm going to convert this to 1 over cosine, okay? So 2 cosine x minus 1 equals 1 over cosine x, okay? And so at least now we're dealing with an equation with just one type of trig function. All right, so now I have this fraction, so I am actually going to do the second thing now, clear up my fractions. So I'm going to multiply all 3 terms, 1, 2, 3, by cosine x, okay? So, and remember, I'm doing that to cancel this one over here. Okay, so when I distribute the cosine x, I get 2 cosine squared x minus cosine x, and then over here they cancel, so I get 1. No more fractions. We have a quadratic here, quadratic in form. So I'm going to set this equal to 0. So I'm going to subtract 1 on both sides. And I'll end up with 2 cosine squared x minus cosine x minus 1 equals 0. And here I will go ahead and try factoring. Okay, so 2 cosine x times 1 cosine x, positive, negative, 1 times 1, negative 2 plus 1 gives me negative 1 for the middle. So this is correct. All right, so now I'm going to go ahead and take each factor, set it equal to 0, and solve. So here I'm going to subtract 1. I get 2 cosine x equals -1. Divide both sides by 2. So cosine x equals -1/2. Okay, so cosine is negative in this quadrant and this quadrant. And it's, sorry, that's completely false. Cosine x is negative in this quadrant and this quadrant. Okay, and it's, we know that cosine is 1/2 at pi over 3. So this one must be 2 pi over 3. And this one must be 4 pi over 3. We've seen this before. Okay. All right. So so x equals 2 pi over 3 and x equals 4 pi over 3. Okay. So we have these two answers right here. Okay. Let's go ahead and solve the other factor. So add 1 to both sides. We get cosine x equals 1. And that happens at 0. X equals 0. Okay. That's one of the ones that we have memorized. Okay, very good. All right, so this is one example where this is what we start with. We have two different trig functions, so we try to rewrite one of them so that we only deal with one type of trig function. So we use the reciprocal identity here, which introduced a fraction, so we cleared our fraction. Okay, and then we ended up with this quadratic in form. And so we used factoring to solve. Okay. All right, let's take a look at this next example. Let's go ahead and solve. Sine 2 theta minus sine theta equals 0 if theta is between 0 and 360 degrees. Okay, so our answer will not be in radians like up here. It will be in degrees. Okay, so let me copy down the equation here so we don't lose the original problem. Okay, so we have the same trig function here, but what's different about this is that this is a 2 theta and this is a theta. Okay, so we've dealt with 2 theta when we had a double angle. Okay, so that's what I'm going to use. So right here, we're going to use the double angle formula to rewrite that. Okay. All right. So hopefully you have your trig sheet available, or maybe you have this memorized. So sine 2 theta is the same as 2 sine theta. So that's nice. We don't have the 2 theta anymore. And so we have this. Okay. All right, and here I see that both of these have sine theta in common. So I'm going to go ahead and factor out sine theta. And I get 2 cosine theta minus 1 equals 0. And so now I have my two factors, sine theta and 2 cosine theta minus 1. So I can go ahead and it's set equal to 0. So I'm going to go ahead and set each factor to 0 and solve. Again, you can only use this idea of taking each factor and setting it equal to 0 and solve if it's set equal to 0. If it's set equal to any other number, then you cannot do this. Okay. All right. So sine theta equals 0. Sine theta equals 0 at 0 degrees. And also at 180 degrees. These are just something that we have memorized. Okay, from the beginning of the class. Okay, this one here, I'm going to go ahead and add 1. I get 2 cosine theta equals 1, divide by 2. Cosine theta equals 1 over 2. So cosine is positive in this quadrant and in this quadrant. The x values are positive in those 2 quadrants. Okay. All right. So that's going to be pi over 3. And then we can't say negative. We can't say negative pi over 3 because actually, we're in degrees. So we will say 60 degrees. We can't say negative 60 degrees because we have this constraint here. So the smallest theta can be is 0. So we can't have negative, right? Okay, so it has to be not this itty bitty angle, but this angle that goes all the way around like this that has a reference angle of 60. So that would be 300 degrees. Okay. All right. Oh, and then the other one, 60. The easy one. Okay. All right. Very good. Okay. So here we use the identities in these 2 cases. Let me try to go all the way up. We use them because here, even though we have the same trig function, one is a 2 theta, the other one is a single theta. So we use a double angle. Over here, we have 2 completely different trig functions, and so we use the reciprocal function so that we have just cosine to work with. Okay. All right. Let's take a look at this next one. All right. So let's go ahead and solve cosine 2 theta plus cosine theta equals 0. So very similar to the previous one. If theta is between 0 and 360. So again, we're in degrees, so our answers should be in degrees. Okay, so what makes this one a little bit different from the previous one is that cosine 2 theta, while we are going to use the double angle formula here, just like we did in the previous example, the thing is that cosine 2 theta, the double angle formula, if you remember, we have those 3 options, right? Let me finish writing this. Double angle formula. Okay. So yes, we are going to do that, but we have 3 to choose from. And so we definitely want to keep everything in terms of one trig function. So if you remember, there's one that's the first option has sine and cosine in it. The second option had only cosine in it. And then the third option had only sine in it. So I will go with the second option where it only uses cosine. Okay, so cosine 2 theta, I'm going to use the option that has this 2 cosine squared theta minus 1. Okay, this is that second option for the double angle formula for cosine. And then I'll bring this down, plus cosine theta equals 0. Okay, so here I have 3 terms, quadratic in form. So I'm going to go ahead and rewrite this in descending order. 2 cosine squared theta, and then plus cosine theta, and then minus 1. Okay, and I will try factoring this. So we need 2 cosine theta times cosine theta. And then we need a negative and a positive. And it's 1 times 1 is the only option. And let's check to see we get 1 for the middle. So outside we get 2, inside we get -1. 2 minus 1 is 1. Okay, so this is correct. So 2 cosine theta minus 1 equals 0, or cosine theta plus 1 equals 0. Solve each one. So I'm going to add 1 to both sides. 2 cosine theta equals 1. Divide by 2 on both sides. Cosine theta equals 1/2. We've seen this before. Cosine is positive here and here. So this is going to be pi over 3. So theta equals pi over 3. That's one answer. And so that's this one, pi over 3. And the one way over here, it's 1/3, 2/3, 3/3, 4/3, 5/3. So this is our answer over here in quadrant 4. Okay. Let's solve the other one. Subtract 1 on both sides. Cosine theta equals -1. So there's only one place where that happens, between 0 and 360, and that is at 180 degrees. Oh, are we in radians? We're in degrees. Okay, so let me change these over here. All right, so we are in degrees, so that is 60 degrees, and this one is 300 degrees. All right. Okay, let's see. All right, let's do 2 more examples. How about you try this one? You might need a little help. Maybe if you get stuck right off the bat, then just watch that first step that I do, and then hit pause, and then you can try doing it on your own. Okay, so let's go ahead and solve this one for cosine squared x plus 4 sine x equals 5. Okay, if x is between 0 and 2 pi. Okay, so if you want to try this one on your own, go ahead, give it a try, and come back. If you get stuck on the very first step, come back and play it just for a little bit, just to see how to start the problem, and then hit pause, and then try the rest of it on your own. Okay? Okay, so here we have 2 different trig functions. We have a cosine and we have a sine. All right, so here cosine squared, we know cosine squared is 1 minus sine squared, so I think I will go ahead and replace this one. So here I will rewrite that as 1 minus sine squared, and then I'll bring the rest of it down. Plus 4 sine x equals 5. Okay, and let's see if this takes us anywhere. 4, distribute the 4, so we get 4 minus 4 sine squared x plus 4 sine x equals 5. We have a quadratic in form, so I'm going to set this equal to 0. So I'm going to subtract 5 on both sides. And I get -1 minus 4 sine squared x plus 4 sine x equals 0. Okay, so I'm going to rearrange this in descending order. So I get -4 sine squared x, and then plus 4 sine x, and then -1 equals 0. I like my leading term to be positive, so I'm just going to go ahead and multiply everything, both sides, by -1. And I will get positive, I will get negative, and I will get positive. And then I get 0. All right, so now I'm going to go ahead and see if I can factor this. So we can try 4 times 1, or we can try 2 times 2. because this is a perfect square and this one's a perfect square, I'm going to try 2 and 2 and 1 and 1. Okay, so and then if that doesn't work, no big deal. We'll just start over and try something else. Okay, does this work? Let's see if we get -4 for the middle. Outside we get -2. Inside we get -2, -2, and -2 is -4. So this is correct. All right, so these are the same factor. So I only need to do it once. Add 1 to both sides. So we get 2 sine x equals 1. Divide both sides by 2. Sine x equals 1/2. Okay. So sine x equals 1/2. Sine is positive here and here. Are we in degrees or radians? We are in radians. So this one is going to be pi over 6, and this one's going to be 5 pi over 6. Okay, so x equals pi over 6. X equals 5 pi over 6. Okay, so let's take a look at the beginning again. So here we had 2 different ones, and I chose to rewrite the cosine squared. Could you have rewritten the sine x? Maybe. Not sure how well that would work out, but maybe on your free time you can try that out. What if you went the other way and rewrote sine x in terms of cosine? Okay, to me, this was the more intuitive direction to go. But again, when you work these out, if you get stuck, you feel like, okay, the method, the thing that you chose to rewrite is not leading you to anything that is solvable, then try a different method. Okay. All right, one last example. Let's take a look at this. Solve cosine theta. Cosine theta minus square root 3 times sine theta equals 0 if theta is between 0 degrees and 360. Okay, so we're back to degrees again. All right, so let me bring this down. Cosine theta minus square root 3 sine theta equals 0. Okay, so we have radicals. We don't want to introduce anymore. Okay, normally when you have radicals, we want to do this method up here. Where is it? Okay, so we've been doing this using identities to rewrite parts of the equation. We've done this clearing fractions. Okay, so this very first one has it. We haven't done this squaring both sides. So this can be useful if you don't see any other way out, or if you see radicals. Sometimes radicals, we like to square them away, our square roots. Okay, so let's maybe try that. Okay, I'm going to get one term on this side and one term on the other side. So I'm going to go ahead and add square root 3 sine theta on both sides. Okay, so I get cosine theta equals square root 3 sine theta. Okay, and I'm going to try that squaring method now. Okay, so if I square this side and I square this side, okay, so that's what we're doing here. We are squaring both sides. Okay, all right, so then I get cosine squared theta equals, when you square a square root, you end up with just the number, and then we get sine squared on this side. Okay, let's see now. We still have two different trig functions, but now that we have squares, we can write one in terms of the other. Probably doesn't matter which one you rewrite. If you want to rewrite sine squared as 1 minus cosine squared, or if you want to rewrite this one as 1 minus sine squared, that's fine. Choose one. I'm going to go ahead and choose to rewrite cosine squared as 1 minus sine squared. That's from our Pythagorean identity. Okay. All right, so now what do we have here? Okay, so I'm going to go ahead and subtract. Actually, let me do this. I will add sine squared theta to both sides. Okay, to cancel it out here, and I will get 1 equals 4 sine squared theta. And then I will divide both sides by 4. Cancel those out. So now I have 1 over 4 equals sine squared theta. And now I'm going to go ahead and take the square root of both sides. So when I take the square root here, I end up with positive negative. When I do the square root here, it cancels the square. So here I end up with plus minus square root of 1 is 1. Square root of 4 is 2. Oh, okay. You know what? Hold on. Shoot. This is also the last example, but hold on. There's a knock at the door. All right. Okay, so back to this. Sorry about that. Okay. All right, so sine theta equals plus minus 1/2. And that happens in all 4 quadrants, right? And are we in degrees? Yeah. All right, so that would be 30 degrees there. This quadrant, it would be 150 degrees. And then over here, it would be 210 degrees. And over here, it would be 330 degrees. Okay, but here's the catch. Whenever you do the squaring, okay, you have to, okay, so let's put a note here. When squaring both sides, must check final solutions for what we call extraneous solutions, ones that we found here but actually don't work. Okay, so let's see. All right, so we think these are the 4. Okay, so let's do our check. Okay, so theta equals 30 degrees. All right, so go back to the original problem, which says cosine theta minus square root 3 sine theta equals 0. Okay, so cosine, and now we're going to plug in 30 degrees minus square root 3 sine theta, and we want it sine 30, okay? And we want to know, does this equal 0? Okay, so cosine 30 is square root 3 over 2. And here, this is square root 3 times 1/2. So does this equal 0? I believe it does. Okay, so this does work. So theta equals 30 is going to be one of our solutions. All right, let's check the next one, 150 degrees. All right, so cosine 150 degrees minus square root 3 sine 150 degrees. Does this one equal 0? All right, cosine 150 is negative square root 3 over 2. Okay, and then here we get square root 3 times positive 1/2. And so does this equal 0? It does not look like it. No, it doesn't. Okay, this does not equal 0. So we are not going to include that one. Okay, the other one is 210 degrees. So let's check this one. Cosine of 210 degrees minus square root 3 sine 210 degrees. Does this one equal 0? Cosine 210 degrees, that's on the negative side. So that's negative square root 3 over 2. Sine of 210 degrees, that is on the negative side as well. So this one is negative 1/2. So does this equal 0? It looks like it does, because this double negative becomes positive. And so yes, 210 does work. And then the last one, 300 degrees. Let's check this one. Cosine 300 degrees minus square root 3 times sine 300 degrees. Does this equal 0? All right, cosine 300 degrees is on the positive side, so positive square root 3 over 2. This one is on the negative side, negative 1/2. So does this equal 0? No, because we have this plus this. So this one does not equal 0. So we are not going to include these two. Okay, so it turns out these are the two solutions for this equation. Okay, so again, make sure you pay attention to this little note. Okay, whenever you are squaring both sides, right? You have to check your final solutions. Okay, so just make sure you do all of this, because if you don't, then what? Then lightning will strike upon you. Okay. All right. That's it for this this section. So one video and that's it. Okay. If you have any questions, make sure you message me, email me, and make sure you check in